Okay, I hope everybody can hear me okay. This is Bill Ayers. I have an introduction to make. We've got Jack Walton, who is our specialist on epSHARE, this particular platform. Jack's going to share with you a demonstration of how this epSHARE works. And with that, I'll turn you over to Jack.
Yeah, hi, good afternoon, everybody. Jack Walton here. So just as a very brief introduction, what I intend to go through is a small introduction to Interica, an outline of the epSHARE platform, and then I'll take you through a live demonstration and answer any questions you have along the way. So first of all, a little bit about Interica. Who are we? Well, we're a specialist data management company servicing the E&P sector. So primarily we provide software and services to organizations looking to better manage their data. So we focus our efforts on producing software and working with companies to install and manage that software across their organizations. We're a team of around about 50 or so individuals, and that's made up principally of geoscientists, data managers, and software developers. We've been in the industry for over 20 years. We work with a large range of companies, from the largest national oil companies through to the small independent operations. And we have offices strategically located in the UK, in Houston and Kuala Lumpur. So we're able to offer that global coverage from our 3 core locations, along with a number of representative agencies in various different locations. Okay, so why epSHARE? Around about 2 years ago now, Interica began to develop the epSHARE application. And what we saw as we set about designing a subsurface EDMS solution is that typically the industry sees a number of patterns, a number of things that have occurred several times over, and we were very keen to build on those learnings. So when implementing an electronic data management system, we looked at other industries, and it was very clear to us that Microsoft technologies are ever growing in their footprint across all industries, but also very much in our own industry, and particularly in upstream data management. Companies are increasingly turning to cost-effective and out-of-the-box functionality, and they're looking to leverage their existing investments. So they're looking to leverage their existing investments in things like Office 365. They're looking to leverage their existing investments in the technologies they already have in-house. Now, one of the things we saw is that, as we all know within our industry, upstream data, subsurface data, has its own complex set of requirements in how that's managed. So what Interica did with epSHARE was to build on the industry-leading EDMS system, Microsoft SharePoint, but to apply our specialist subsurface data knowledge to that to customize it to the end user's requirements. So our approach to that is slightly different to anything that we have seen in the market before. What we have done is built our epSHARE application inside of the Microsoft SharePoint framework. That enables companies to seamlessly integrate that to their existing environments, whether that's a cloud-hosted Office 365 environment or an on-premise environment. It doesn't matter. epSHARE can sit within those existing architectures and those existing installations. What we did was to take that framework and customize it for the subsurface user. So we've done that with applying, at face value at least, in applying 2 industry-leading technologies on top of that, or 2 industry-leading to industry-leading frameworks. So initially, we have used a PPDM data model on the back end. PPDM is the Professional Petroleum Data Managers Association. It's a framework established by some of the largest oil companies to enable them to standardize metadata across subsurface data types. And the second element that's very familiar to geoscientists is that we've implemented a GIS front end to the data. So we're able to search for the data geospatially in a way that's very familiar to geoscientists, subsurface technologists, explorationists, etc. So with that, I'll just jump into a very quick demonstration and take you through some of the functionality of the system and how it looks and feels to a user. So what you're seeing here is an epSHARE landing page. Now this is a customizable page. This is a demonstration example we have built for the Taranaki dataset, courtesy of the New Zealand government. So this is not a real oil company's environment, but this is a landing page that we have built based on our experiences with what a lot of companies lack and how best to leverage the SharePoint framework, not only from a data management perspective, but also from a communication perspective. Now, what I mean by that is that out of the box, a standard SharePoint implementation offers a lot of functionality in collaboration and communication. Now, what we've done with epSHARE is to leverage that, but apply that subsurface expertise to it. And some of the ways in which we've done that is to create team workspaces. So these are collaboration centers for individual groups of users. Now, in our world, that might be assets. We might differentiate our teams by assets. We might differentiate our teams by discipline. We may have an area for petrophysicists and an area for geophysicists, for instance. But in essence, we see a drive within the industry to adopt teams. Now, that's not just within our own industry, but across technology as well, with the advent of Microsoft Teams, for instance, Office 365. These collaboration environments are developing at a great speed, not only due to perhaps some of the newer challenges we're seeing currently with people working remotely and with people working out of office and teams spanning multiple locations. But I think as a growing trend, it's something we were seeing across the industry starting to occur. Teams were increasingly looking to bring in specialists that may not necessarily be in the same office as the rest of their users, but it became increasingly important to create these areas where the teams could collaborate in a secure environment. And that's something we can offer with these team workspaces. On top of that, we've implemented some very simple team calendars. This would be somewhere that a subsurface group, an asset group, a discipline group could communicate and collaborate, perhaps as a TCM, perhaps as a HSE meeting coming up. It's a central portal for communication. That's the last I want to mention on what I'll describe as the very SharePoint-centric features. But what I want to take you into now is the epSHARE data portal. This is the principal feature and the principal purpose of this demonstration. Okay, so what you guys will start to see as the bandwidth catches up is an Esri GIS map. Now, this is a map of offshore New Zealand, and what you can instantly see is a rich level of detail with regards to individual wells, seismic surveys, block and basin boundaries, and cultural data. This is our GIS front end. And what you'll see here on the back end is our data portal. This is the component that actually stores your subsurface data. Now, our approach to this is somewhat different to what a lot of companies would have seen and tried before with adopting an EDMS for their subsurface data. Now, typically, what I've seen and what the experiences of the industry suggest is that oftentimes companies will use a shared drive for managing the data of an asset. And they'll implement a taxonomy within that, a folder and file system hierarchy, as an attempt to standardize or to add metadata to the files that live within those folders. Now, oftentimes these hierarchies grow exponentially and they become very cumbersome and difficult to manage. We see a reliance on tribal data. By that, I mean, if I, as a user, were looking for a particular well log, for instance, or a particular report, presentation, whatever it might be, seismic line, should I not be able to find it easily, I would walk across the office and talk to John, who's been in charge of that asset for the last 5 years and knows intrinsically where he's filed everything. That's great in a one-to-one working environment where we're all in the office, but of course that's not the reality of today. So we see an increasing need for users to be able to sift and sort through their own data in a way that's increasingly simple and increasingly efficient. Users often spend far too long looking for data that may or may not exist. And what we see is those in-house taxonomies perpetuate that problem as they grow. The way in which we have tackled that problem is to utilize the data lake technology. What a data lake is, as opposed to a taxonomy, is effectively an architecture whereby we store data at the L1 level, at level 1. Instead of using a vertical taxonomy, we use a flat system whereby each file contains the metadata alongside the file, as opposed to in the folder name. So traditionally, if you think about that in your Windows Explorer style view, each folder name represents a metadata tag that you would ideally like to associate with the file below that. Now, the problems with those, as I've said, they grow and they become non-standardized, but also technically, we see issues with 256 character limitations within Microsoft. So as the file path grows, we run into complications with saving and searching for that data. In a data lake environment, that doesn't happen. As an added benefit to that, I have the metadata alongside the file, but also I benefit technically in the speed of searching being vastly increased in a data lake. Now, in this demo system, we have our data organized into 5 different lakes, if you like. We have well data, 2D and 3D seismic data, general business data, and general geology data. There are no limitations to the number of additional lakes we could install here. Perhaps a company has a specific requirement for drilling or reservoir engineering or geophysical interpretation projects. We can accommodate those requirements. That's very simple within the system. Now, you will also have seen here what appears to be a taxonomic structure on the left-hand side. In truth, because this is a data lake system, this taxonomy is in fact a set of it's a virtual taxonomy. It's a set of logical filters across the metadata. But this is based on our PPDM 3.9 model. So PPDM is a set of relational data tables that tie in metadata to specific products. What we have done is taken that, worked with the PPDM organization, and created a virtual taxonomy that we can apply to a data lake so that a user can search in a way that would remain familiar to what they are currently doing today. And I'll show you how that works in a few moments. What I would like to do at this point is just take you through a couple of simple scenarios of searching for data. And And then I'd just like to demonstrate how we can then interact with that data, how we can then leverage the EDMS technology underpinning epSHARE. And then I'll also show you how we can load data to the system and take advantage of a lot of automation that we've built into epSHARE. So first of all, there are a number of different ways I can interact with this map. I can search for individual items by perhaps navigating to an area. I can make use of some of the Esri technology in searching for an area, typing in keywords. If I click on a feature on the map, you can see here I have collected the Kupi-1 well, and I can see the header information for that well. And at this point, I could verify that this is or is not the well I'm looking for, perhaps, and perform a search on that. Equally, I can, as you would expect, toggle on layers. Perhaps I'm not interested in seismic, perhaps I'm only interested in wells. All of the features you would expect to see with an Esri GIS layer here. It is important to stress at this point, if you are already an Esri house, you already have your own GIS system, we can integrate that into epSHARE. So if there are cultural layers that you already have available in your organization, perhaps field boundaries, pipelines, block basins, whatever it may be, we can integrate those as well. The final point I'll make with regards to the GIS underpinning epSHARE, we can integrate with Esri, but we also offer a GeoJSON, which is an open source map that we can implement here for those companies that perhaps don't use Esri. Okay, let's go through a couple of simple searches. So I want to search across a series of wells. So I select my well header from the drop-down, and I simply drag and drop over an area. I can see here that I have 13 wells selected. And now what I want to do is filter the data in my data lake to show me only the information that pertains to those map selections. And this is really quite simple, but it's very powerful at this point. So I want to just highlight here that in this demo system, we have a small but very representative data set. It's just under 23,000 items. Now I'm going to send that to epSHARE. And what this is going to do is filter my results very, very quickly down to the individual records that contain any reference to those particular wells. And you can see I now have 437 files to look through as opposed to 23,000. And that was a fraction of a second across a home broadband connection to an epSHARE system running in Microsoft Azure. So you can appreciate this is very quick. And that pays tribute to the architecture underneath it with the data lake. Now from here, I want to refine my search a bit further. So I could perhaps search across the metadata fields, or I could decide I would like to search for a particular product. According to PPDM, there are around 180 or so products that one would expect to be associated with any given well. Now, what I'm showing you here is not 180 options. The epSHARE system is smart enough to only display the products for which it has data available. So what that means is from a user perspective, if I'm looking for final well reports across that field, if I don't have that option displayed, I can have confidence that data doesn't exist in the system. I select final well reports, and in less than 30 seconds, I have filtered on an area on a map and told the system, show me all the final well reports for this area. Now from here, I can now interact with this data. I can see who has access to the data. I can see who it's been shared with recently. I could open the document, modify the document and work on it. Or I could perhaps look at the document and I might decide that I want to look at the previous versions, the previous iterations of any given report or presentation. And so I can see that the document was last updated in 2019. Perhaps I want to investigate version 3 that was Stan's version, for instance. And from within here, I can simply restore a previous version of that data and take a look or interact with that. At this point, we are leveraging all of the underpinnings of Microsoft SharePoint. Equally, I could create advanced workflows that perhaps go so far as to say, before this document is shared with a contractor resource or with a third-party resource, it must be approved by the team leader. Now, that might be something that you manage in-house by transmittals and email requests, but it's something we can build into the system very quickly to say, Jack, before Joe Hardy sends this document to Bill Ayres, it must be approved by you. Tick to accept. Very, very simple. Equally, I can check the data out of the system and restrict access to that data for a period in time whilst perhaps I update the system. I update the version of that data. Equally, if I wanted to share it with a resource, I can invite people to share the data, to look at the data, and I can select their permissions. Jack Walton can only view this data. I'm therefore allowing Jack to see the data, but not to modify it. When I, as the recipient of that invitation, open the data, I'm opening that data on the system where it sits in situ. So where you might have sensitivities with data sovereignty, you are not in fact breaking any of the rules with that. You are viewing the data as it presents itself in, say, the UAE, even if you're sitting in your apartment in Jakarta. The data has not physically left the country. It's still on the system in the office. You're just accessing it from home or from a remote location. Okay, let's repeat some search and let's show you how the PPDM taxonomy works. So let's resend my selection to epSHARE. We're back to our 430 documents, but perhaps I don't want to sift and sort through the columns. Perhaps I don't want to select the individual well. I just want to browse through the data in a way that's very familiar to my existing system, my existing file shares. I can navigate down through our virtual taxonomy, our metadata filters, and I could say, show me all logs, show me all my mud logs, for instance. And I select mud logs from my drop-down. And at the same time, that has selected the child folders below mud logs, lithologies, samples, and shows. Now, this taxonomy, this PPDM taxonomy, is incredibly shallow. It never exceeds 6 layers deep. So what that means as an end user is that within 6 mouse button clicks, I can find the exact document in the system that I've been looking for. I often challenge companies to repeat the same with their existing system. And rarely, if ever at all, does an in-house folder taxonomy match the performance of the epSHARE system. I hit the filter button, and the system shows me the 46 mud logs we have available for that entire field. And again, from here, I can then interact with the data, open it, share it, follow it, and work with it in a way that's very familiar to anyone using any of the standard Microsoft tools. Okay. What I would just like to show you guys now is a brief example of how quick and easy it is to load data to the system. So you can get a sense of how even working in a collaborative environment or working from home, how easy it is for an individual user to pick up the pick up the mantle of their own data management, load data to the system, and apply some governance to that automatically. So let's say I want to add a well document to the system. Within epSHARE, we have a framework that says, provided I can give you 2 pieces of information about a file, the system will automatically apply metadata to that file, and it will automatically place it in the correct location in our virtual taxonomy. The way in which we do that is by selecting a parent ID. In this case, it's a well ID. So I need to tell the system that the document I'm loading references the Ahuroa South B1 well. And then I need to tell the system what type of document is it. Let's say it's an AFE. You'll see here we have a file location. But in fact, this is grayed out. That is because, of course, the file is actually being stored in a data lake. But what we're showing you here with well/operation/AFE is its location in our virtual taxonomy. Let's pick a file. Let's pick the dummy file. And let's hit OK. Now, what this system is now going to do is take us through to a metadata validation page. Now, you'll see what's happened here is that the system has automatically populated the vast majority of these metadata fields. Now, the way in which that has compiled this is because I told the system that this document is going to belong to this well. So the system underpinning it has a parent-child relationship between geospatial assets, well locations, blocks, fields, basins, seismic lines, whatever it may be, and its child data. So much like DNA, I inherit that information down. So when I've selected AFE for that particular well, the system has gone, okay, I know that the Ahuroa South 1 well is in the Taranaki Basin. And I know that the surface lat longs are these coordinates. And I know that the surface elevation is 201.8. Now, what the system has also done at this point is based on the product selection, it has configured a set of requirements against the metadata fields. Now, there are 3 classifications for the metadata fields: preferred, mandatory, and optional. And that configuration changes based on the product selection. So, for example, in a final well report, I would expect the completion date to be preferred or mandatory, because that information is likely available in a final well report. In a daily drilling log, I would not expect the bottom hole location to be a preferred or mandatory field. I wouldn't expect the total depth to be available because, of course, we're actively drilling. No, we don't know the total depth yet. So I would not enforce the water depth or the total depth to be a mandatory field in a daily drilling report. But by applying these classifications on a product by product basis, what we encourage and in fact enforce is good data management policy across the organization. And this really comes to its own in ensuring that your company's investment in a system like this does not erode over time with what we might describe as, let's say, laziness from the users loading the data. If I don't have that metadata available and it's a mandatory field, I must go and look for it. I must find that and upload that. If it's a non-mandatory field, I can continue without that. But it just enforces good data management moving forward. And of course, once the system has been populated with the metadata field once, it remembers them and applies them to all future data loaded against that well. So I will only ever fill in the metadata for this well once, and forevermore, any other user or any other data loaded against that particular well will inherit that metadata. So again, it drastically reduces your overhead in managing the system. It drastically reduces the time in searching for the data. And in a remote environment where communication can become more difficult, it encourages us all to work from a gold standard central repository, and to ensure that the value of that is maintained over time. I hit save and that data will become available in the system. We can see there, dummy file is available. And that really, folks, is the final thing that I would like to show you. This is a very high-level overview of the system. There are a number of other features I could take you through in infinitely more granularity, but as an overview, I think this is possibly enough to hopefully get you guys thinking about how this might work within an organization like your own, how this might meet some of the challenges that you're currently facing in, let's say, rapidly evolving work environments. And at this point, I would hand back over to Bill and Joe.
Thank you very much, Jack. Okay, then I'd like to thank you all for taking the time out of your busy days to spend this half hour or so with us and learn a little bit about epSHARE. And certainly if you'd like to get us to present in perhaps a very more structured detail for your particular needs with your team, let us know. We're happy to help you as much as we can. Thank you.